Alright, here we go. This problem, pretty good problem. It's really tricky. You got to rely on your math skills to get the right answer for this one.
That's a lot to rely on.
Number 53 reads, a basketball player is trying to make a shot, a half-court jump shot, and releases the ball at the height of the basket. Assume that the ball is launched at an angle of 51 degrees above the horizontal and a horizontal distance of 14 meters from the basket. What speed must the player give the ball in order to make the shot? So, I got this drawn up here. Here's the player shooting the ball, same height as the basket. Never knew they made players that tall, but cool, whatever. So, he's shooting at 51 degrees, and we're trying to find this right here. We're trying to find that velocity. And what else we know is that the ball is at a distance of 14 meters. Woo! That's it.
I think when they do something
I
like
seen
that,
that guy
here's
watching
this
the
in
game
class
last night.
tonight.
There was a player from North Carolina went up Mr. Hall to dunk and like got rim stuff hard and
Yeah, he
failed.
did.
I was like, I was like, that would be embarrassing. Brady Evans.
Alright. So this is the key. Down here I drew out this triangle. So what we're going to do is just break this triangle down to the velocity, the x direction, velocity in the y direction.
Yes.
Hey,
Alright. Shh. Focus. Thank you. Alright, so from here you don't have a lot of information.
No.
But you have everything you need to get an answer. All going to come from working in the x direction and working in the y direction. So starting to work at that. What?
Is it camera on?
Yeah.
Oh, we were wondering, but okay.
Alright,
I was trying to like not say that loud.
so let's start working in the x direction. Let's write down everything you know for the x direction. So in the x direction, I know my x initial,
0.
0 meters. I know x final, 14 meters. So, x initial, 0 meters, x final was 14 meters. This is 53. Alright, what else do I know? What's acceleration? How do you know it's 0? Because it's constant, it's in the x direction, nothing, no force or anything's active for me. Exactly. So acceleration 0. I got the velocity of x, but I don't know it. And velocity in the x direction is the same whether it's initial velocity or final velocity. It's the same throughout. Here's the key to this. What links the x and the y direction together? Guess what you're going to have to do with the x direction and the y direction? You're going to have to link them together using time. We don't know time. But there's formulas we can use to get some information. So x final equals x initial plus initial velocity in x direction times time plus 1/2 times acceleration times time squared. This is useful to us. Why? Because we do not need that 0. I mean the initial position 0 and acceleration 0, which cancels these terms out to leave us with the final position is equal to the initial velocity in x direction times time. Remember, you're trying to link everything together using time. So solve this to be set for time equal to final position divided by the initial velocity in the x direction. You're going to do the same thing for the y direction. It'll be a little more interesting. So the y direction. What do we know in the y direction?
Positions are both
Positions are at 0. Exactly. So y initial, I'll make it 0 meters. We're going to make y final. It's at the same spot. And the reason I know it's at the same spot is because it says that the ball is released and shot at the height of the basket. So they're both at 0 meters. That's a good thing. Y initial equals 0 meters and y final equals 0 meters. What else we know?
acceleration's negative 9.8.
Okay, so acceleration is gravity, which is negative 9.81 meters per second squared. So with that, we're saying that down direction is negative. Anything else? Don't know the velocity. Velocity in the y direction. Now this is the thing. The velocity, the initial velocity in the y direction is here. It's equal in magnitude, but opposite in direction with the final velocity in the y direction. Reason why. What happens? The ball goes up until it hits the highest point here. Once it hits that highest point, what happens then? What's accelerating it? Gravity. Gravity was pushing it back down, accelerating it downward as it was coming up, and now it's accelerating it downwards also. It's covered the same amount of distance, and it's covered it in the same amount of time. So, it's equal to each other. Just opposite in the direction. And then we don't know time. Okay. We're going to do what we've done. Let's see, is that right? Is that what I'm going to do? I did it that way. I'm going to do this. Final velocity equals initial velocity plus acceleration, which is gravity times time. Everybody good there? I'm trying to get everything in terms of time, with terms that I know. So with this, final velocity minus initial velocity in the y direction is equal to gravity times time. So time in the y direction is equal to the final velocity minus my initial velocity, all divided by gravity. And here's the thing. I know that the final velocity is equal to the initial velocity, just opposite magnitude. So I can substitute this in. Opposite initial velocity minus initial velocity all over gravity. Does everybody see where that came from and how I got to do that? This is the part where I thought people would have questions. So I'm expecting questions.
So, how do you
I used this right here, this idea that where the ball's released at the same height of the basket. So my starting position and my ending position in the y direction is the same. Since that, my initial velocity in the y direction is making the ball go up, right? But right here at this point, it stops moving up and it starts to come down. It takes the same amount of time to go from here to there as it does from that midpoint to the basket. So acceleration is gravity throughout the whole thing. The velocities in the y direction are equal to each other in magnitude, but they're opposite in direction. Because my initial velocity is going up, so it's positive, but my final velocity is going down, so it's negative. Does that make sense? I got 2 nods, and I'm getting stares.
get it?
Okay, I'm getting some nods. Okay, I'm going. All right, here's the problem. I have too many variables in this case. I don't know time and I don't know these velocities. I don't know time and I don't know this velocity. It's not helping me. I can link these two together, which is what we're working towards doing. So let's link them together with time. All we're doing is substituting. You've done this before in math a bunch of times. So all it is, the x final divided by the initial velocity in the x direction equal to time, which time is also equal to the negative initial velocity in the y direction minus the initial velocity in the y direction divided by gravity. Any questions?
Yeah.
Which question?
I'm gonna look at it first.
Okay, take a minute.
Why is both the initial y velocity?
This is what I'm looking. I'm wanting this to be the same. So what you can also do is put these two together. So minus 2 initial velocity of y. I've linked everything together with time. The whole thing, this whole process I'm doing is I'm looking at it and I have too many variables. I have some things I know. I know my final position in the x direction. I do not know my initial velocity in the x direction. I do not know my initial velocity in the y direction. I know gravity. I have two variables. You cannot solve an equation with two variables unless there's a second equation you have for it. I'm trying to get everything in terms to where it's one variable. I know this is like completely new and this is
Yeah. Pretty much.
Pretty.
this is what I'm, because if I stayed here, if I stayed at this step, then I have three variables I don't know. See, I got time I don't know, I have the final velocity in the y direction I don't know, and I have the initial velocity in the y direction I don't know. At that moment, I'm like, I gotta cut this down. Is there any way to cut this down? I can, by using this idea. These have got to be equal in magnitude of opposite direction. So I can put to where this is the initial velocity in the y direction. So now I only have two variables I don't know. So then I link the two together, which gives me this. I still have two variables I don't know. Is there any way for me to link it to where there's one variable that's unknown? Using your triangle. Why? These component vectors add together to give you this vector, that velocity vector, which we're trying to find. So, working this backwards, just use what you've used before. Okay, we're just going to go with our normal, everyday trig. I'm trying to find the velocity in the y direction. These are both of these are initial. So I'm trying to find the initial velocity in the y direction. The sine of 51, opposite over hypotenuse. So the velocity, hopefully I can jump. The initial velocity in the y direction is equal to the velocity times the sine of 51 degrees. And the velocity in the x direction, the initial velocity in the x direction, is equal to velocity times the cosine of 51 degrees. Does everybody see how I did that? I know I skipped some steps there, but the only thing I did was trig and one step of algebra. Because the sine of 51 degrees would be equal to the opposite, which is the initial velocity in the y direction, time the divided by over the hypotenuse velocity. Gosh, I'm still tongue-tied right now. Multiply it out, get the initial velocity of the y by itself. Is everybody good? I need like some reaction here because everybody's just looking at me.
We're good.
Yeah.
Okay.
Looking good, feeling good.
Now we can substitute in again. So what I have is the final the final position in the x direction divided by this initial velocity in the x direction is equal to velocity times the cosine of 51 degrees, which is equal to
This is a lot of stuff.
a lot, I know. Negative, and substitute in for this.
Hold on one second, just.
Okay.
Just hold on 1 second.
Is this one up, please?
Oh my gosh. Can't. Oh, this
All
isn't
is
even
fair
on
game.
the no hard problems. Like
That's
this is,
circular motion. This stuff, yeah.
What's circular?
Don't worry about that right now.
So when you get the little, the velocity times sign, stuff like that, you're just gonna plug that answer into what?
I'm just going to plug it in over here.
Okay.
So this is what I'll end up with.
What's velocity?
The velocity.
No, you didn't.
That's what we're trying to find. Like this V right here is what we're trying to find. So the velocity, initial velocity, negative velocity times sine 51 degrees minus velocity times the sine 51 degrees, all divided by gravity. This is what we've been working for. We've been trying to find one variable we do not know. Do I know the final position in the x direction?
Yes, sir.
So I know that. Do I know velocity? No, I'm trying to find it. You can put cosine 51 degrees in calculator, you're fine. Okay, this velocity, it's the same thing as over here. These are the same variables. And then I know gravity. So now I'm down to one unknown.
So you solve for it.
I can now solve for it.
That's all.
But it's all based off of this right here.
That's crazy.
I know we worked a lot on that one.
I know why you put it in brown.
Okay, is everybody good on this? I'm going to erase this because I need more board space.
Okay.
I guess.
Okay. So this is what we got. I'm just going to transfer this over. X final divided by velocity times cosine 51 degrees is equal to negative 2 times velocity of the sine of 51 degrees. That 2 came because I combined these two terms together. They're exactly the same, I just added two like terms together, which gives you a negative 2. And all this divided by gravity. I'm going to solve this thing to where I can get the velocity by itself. Alright? So I'm going to end up with x final times gravity is equal to velocity times cosine 51 degrees times the negative 2 times velocity times the sine of 51 degrees. That's what I was looking to make sure. Thank you. Now I'm going to add some like terms together, okay? I'm trying to take it slow. I know it's overwhelming. Final position times gravity is equal to negative 2. I'm just going to pull that right out in front. Times v, which is velocity squared. Was that as a question, or you don't like this?
As in, hold on.
Okay,
I got you. Got it.
you got it?
Got it.
I just multiplied those two velocities together.
Sure.
Times the cosine, 51 degrees, times the sine, 51 degrees. I want to get velocity by itself. I'm going to put one big huge algebra step in here, all right? Velocity squared is equal to final position in the x direction times
Carol
gravity
Rose, come to the office. Carol Rose.
divided by -2 times the cosine of 51 degrees times sine 51 degrees.
And then you the square root of it.
Take the square root of velocity is equal to the square root of final position times gravity divided by -2 times cosine 51 degrees times sine 51 degrees. Filling that in. Final position in the x direction is 14 meters. Times gravity. Gravity is -9.81 meters per second squared. I still put that negative there because I chose my axis for the negative to go down. You have to stick with that, because if you don't, this -2 is going to give you an imaginary number. All of this is divided by -2 times the cosine 51 degrees times the sine of 51 degrees. You can finally put this in a calculator.
I love problem like these. Yeah, here we go.
I'll look out. Mine's still in here from yesterday. It's okay. It's okay. I got 11.8494 meters per second is the velocity the basketball player has got to shoot the ball to get it into the basket. Does everybody feel?
Well, I was feeling
I'll let you
pretty
know.
good. That's the same
Oh, that's what I
problem.
got. Let's go.
You got that?
Yeah, man.
What's your questions?
Why was that one so hard?
Why is this one like that?
Because it's dictating what you know and what you're given. I can dictate how you're going to work a problem by what I give you.
I hope you wouldn't do that. That I do feel, golly.
It's
little
tough.
Failure.
But with this, the reason we had to do it this way is because we didn't have enough information to do it any other way.
So if they would, what could they have gave us to make it like? If they gave us one more thing.
If they would have gave us a velocity in the x direction or velocity in the y direction, we would have been golden. Because if they would have done that, we could have just done trig. But they didn't.
Because they're little means.
Another question they could ask you for is what angle does he have to shoot the ball at? But then they'll give you all this information here, like it lands 14 feet away, stuff like that. And then you got to work backwards. It's all based off of what you're given, where you're going, how can you get there. It's kind of like you're given a handful of stuff. And I said, okay, with that handful of stuff that you're given, get to this. You have to fill in the middle part. You have to fill in the journey. You have to figure out how you're going to get there.
It's like all man.
This was a lot of math. You had to use math.
They give us one problem. 20 problems in that problem.